Hello everyone, today we're diving into the fascinating world of async programming. If you're new to the concept, don't worry, by the end of the video you will have a solid understanding of the basic concepts. So let's get started. Async programming, short for asynchronous programming, is a method that allows your program to start a potentially long-running task, but then move on to other tasks without having to wait for that task to finish. What's a long-running task? Well, a typical one will be calling an API. There's a lot of overhead when calling APIs. You have to traverse the network, possibly the internet, go through firewalls, encryption, decryption, process the request, which means that probably at some point you're going to connect some database, query the database, run some logic, so on and so forth. And then when the server is ready to return the response back, it has to do that all over again. So, yes, that is a very long-running task. But yeah, in this day and age, this whole process may only take a second. But don't forget that in computer time, even for human users these days, a second feels like an eternity because everybody's so used to really fast and responsive experiences and doing multiple things at the same time. So if your application is taking a second between every click or tap, they put your users off. And that's where async programming comes in. There are three main reasons for using async calls. The first one is improving performance. Not because async calls run any faster than sync calls, but because you are increasing the amount of stuff that you do at the same time in parallel. By not having to wait for a task to complete before starting another, you can do more in less time. The second one is making the most of the power of the machine running the program. Async allows for what is known as non-blocking operations, meaning your CPU is not stuck doing nothing waiting for a task to complete. It is free to work on other tasks. And finally, async tasks can dramatically improve the user experience. That's because users are not staring at loading spinners every time they interact with your application, making everything feel very responsive and snappy and allowing them to do multiple things while your program works on the background. Okay, so what is the difference between synchronous programming and asynchronous programming? And when should you use one over the other? In synchronous programming or sync programming, tasks are performed one after another. So if a task takes a long time, it hogs the machine resources and blocks all the other ones, causing delays. It's like all tasks are standing in line waiting for their turn. In async programming, tasks can be initiated then left to be completed in the background while other tasks continue to run. No more waiting for one task to finish before you can start a new one. But wait, why don't we just use async programming for everything then? Well, like anything else in tech, of course, there are trade-offs. Async programming creates a lot of overhead. To begin with, the program has to create a checkpoint. Then it needs to set up a mechanism to be alerted whenever it is good to go again and it can resume processing. Then it needs to remember where it stopped, and then it needs to join up back with the program at whatever state it finds itself at that point in time. So this can be very inefficient for operations that could be handled much more quickly by sending them directly to the CPU. So the rule of thumb is to use sync programming when you are dealing with CPU-bound operations, such as calculations or data processing, and then use async programming for when you are dealing with I/O input-output bound operations, such as network requests, or for example, when dealing with files and databases. So how does async work in code? Well, languages have many different ways of expressing and handling async calls, but the good news is that for many decades now, they have been following very similar patterns and conventions. So most of them will have two magic keywords, async and await. The async keyword indicates that a function should be executed asynchronously. That gives the language runtime a chance to set up all that overhead that I just talked about before. The await keyword is the one that you use to actually start an async call. When the language runtime encounters the await keyword, it will create a save point on that line of code and then resume from there once the task has been completed on the background. Like I said, most modern languages are very consistent with this pattern. This is true for Python, JavaScript, Java, C#, and even new languages like Rust and most other ones. They all have this async await pattern and keywords. I am working on a video which is a full tutorial that will take you from zero to hero using async code in Python, but if you are interested in a similar thing for any other language, do let me know in the comments. Please check the links in the description for further reading. Thank you so much for watching. If you learned something, please like and subscribe. See you on the next one.